Okay, we're back here, Algebra 1, and we're on to Section 2.6, Ratios and Proportions. I know that you guys have seen some of these before, and we've actually done a little bit of work on this already in past sections, but maybe you didn't know that actually what you were doing was cross-multiplying and solving proportions. But so we're going to compare ratios and solve proportions today. Now, what is a ratio? It's a comparison of two numbers by division, okay? We can write this a whole bunch of different ways. If we talk about like x to y, if these are our two numbers, we can write it like this, x to y in actual words. You can write it like this, x with a colon in there, y, that's still read x to y. Or we probably see it most likely in a fraction form, x over y. And that's how we're going to kind of use it mostly. What is a proportion? Proportion is an equation stating that two ratios are equal. So you need two ratios, and you just got to have an equal sign in the middle of them to make it a proportion. So a ratio we got to think of as a fraction, and then a proportion we would have equal fractions, two equal fractions. Okay. So an example would be, say, of a proportion. If we had, let's go with x over 6 equals 1 over 3. And you might be able to just figure that out on your own, but there are strategies in which we could use. Sometimes it's a little harder. You got to use a little extra work. But this would state that these two fractions are equal, and we'd have to solve for x. That's what we're going to kind of be doing today. Okay, so first practice problem, determine whether the ratios 4/5 and 24/30 are equal ratios. So I'm just going to write, if it's an equal ratio, then we'll put 4/5 equals 24/30. But really, there's a question mark here because we don't know. That's what we're trying to figure out. So there's two different ways in which you can go about doing this. First way is to simplify, and just simplify both fractions and see if you get the same answer on both sides. And the second way is to cross-multiply. And I'm actually going to go to cross-multiply first because I just think it's the faster way, and I think it's the easier way. But you calculator people, might be able to do it in your calculator a little faster. So let's go to cross multiplying first. So if we just take 4 times 30 here, that's going to give us 120. And then the other cross multiply, 24 times 5, would be 120. So is that equal? Yes, it is. Yes, so those would be equivalent fractions. The other way in simplifying that you could do is you could just simplify the fraction and say, let's take 24 and 30. What goes into both of these? 6. So if we divided them both by 6, we're simplifying, then we'd end up getting, 24 divided by 6 is 4. 30 divided by 6 is 5. So we have 4/5 and 4/5. Those would be equal as well. Okay, so two different ways. Cross multiplying, if you get the same cross product, then they're comparable, or you can simplify and get the same fractions. Okay? Let's talk a little bit about this. This word here, means extremes property of proportion. All that means is a lot of word jargon just to say basically cross multiplying. That's what we talk about, cross multiplying. We don't even need to put the words up there. Your means are the bottom left and the top right of a fraction, and your extremes are the top left and bottom right. Not really important. Doesn't really matter much. So thinking about symbols, we're just kind of giving you the process of cross multiplying and where it came from. That's not an equal sign. I don't know what that is. Okay, so we have A over B equals C over D. Basically, the cross product, cross multiplying, or the means extremes property of proportions. I'm not going to ask you to say it like that. You can say cross multiply would tell us that A times D should be equal to B times the C. And I don't even think we need an example with numbers. We kind of did one the last time, on the last page. All right, so let's practice. Let's go to practice on letter B. Letter B. And you can do decimals over here, and you can have decimals in your ratios. It's no big deal. And letter B, but let's go right to letter B here. It says what, 4/10 over 8/10 equals 7/10 over 1.4. You can do that. You can have decimals in your ratios, no big deal. So I'm going to cross multiply again here first, and we're just going to take a look. And simplifying, you could try to simplify. Just understand your calculator may have some problems simplifying because you're putting fractions in, so you might have to use the divide tool and see what you can get here, but or turn it into decimals. But anyways, I'm going to cross multiply first here. I'm going to go 6 times 28, and that's going to give me 168. And then 24 times 8, punch it in your calculator, or if you use mental math, 192. So right off the bat, I can see those two. We got our question mark here. Those two are not equal, so that's a big fat no. No, not good. If you were to say, simplify here, 6 over 8, what goes into both of those? We'll set it equal to 24 over 28. Let's see. Or we'll just put them here and see if they both get the same answer. So what can we divide both of these into? Well, they can both be divided by 2. 2 goes into both of those. So you'd end up with 3 over 4 here. And what about 24 and 28? What goes into both of those? Well, 4 does. So let's go and divide by 4. You get 6 over 7. So you can see right here that these two are not equal. Not equal. Okay? So you can use either way, simplifying or cross multiplying, but you need to show your work. So if you're going to use cross multiplying, this over here is your work. And if you're going to simplify, then this is your work over here because I need to see that you're actually doing the division. Okay? Okay, solve. Now we're going to solve the proportion. So let's go right down to number 4 because I like the idea of it having a 2 plus w here. So we kind of already did these in what 2.4b was it, where we had fractions and we're trying to solve equations with fractions in them. And one of our strategies was to cross multiply. So we can cross multiply here and solve. And I'm just going to put parentheses here just to let us know that we do actually put them in. We have to multiply everything by there. So you're going to have 9 times 2 plus w. And then that's going to be equal to 12 times 6. Or 6 times 12, either way you want to put it on the other side. Now we have to do the distributive property, 9 times 2 and 9 times w. So I have 18 plus 9w. And 6 times 12 on the right side is equal to 72. So now I've gotten rid of my parentheses. I'm all set. I've got my variables on one side. I just have to get this 18 over to the other side. So I'm going to subtract 18 from each side. And now I'm stuck with, I've got what, 9w equals 54. And now we know if I go ahead and divide by 9 on each side, I get w equal to 6. Very simple there. So again, I just did my cross multiplying. I had to do this distributive property, and then I was just solving a two-step equation, basically. Okay, we can check our answers here, too, if we just plug in this 6 that we got for our answer, plug it in for w, and see, okay, well, 2 plus 6 would be 8 over 6, and then equals 12 over 9. And so you could check that here now by using your cross products, or you could simplify and see if they're if it turns out to be equivalent fractions, which they do. All right, next up, rates and unit rates. We'll talk about rates. We use these things all the time. A rate is a ratio of two measurements having different units of measure. So two measurements, but they have different units of measure. And then a unit rate, when we think about a unit rate, all that means is that your denominator equals 1 unit. So you've seen a whole bunch of these, and we use these all the time. How fast you're going would be like miles per hour. When you start driving, you're going to be concerned about gas mileage, so miles per gallon. How many miles can you drive on 1 gallon of gas? And then if you get a job, the other thing you're going to be concerned with at some point is dollars per hour. That's always an important one. Okay, dollars per hour. So we've got that, miles per hour, miles per gallon, dollars per hour, things like that. Okay. And along those lines, you could figure this out with a ratio. A ratio. Let's say you were driving in a car and you were able to travel 300 miles on 8 gallons of gas. Okay. Well, we could divide that, and we could get our answer of how many miles per gallon, and that would be the unit rate because you divide that, you would get the 1 gallon. How many miles per 1 gallon would give us the unit rate. Okay, going further down here, scale. A scale is used to make a scale model of something that's too large or too small to be convenient at actual size. So something that's too large would be maybe the solar system, something too big to actually put in an actual size, or the entire Earth, things like that. I use it for maps a lot. Something that's too small, maybe a model car, or those little Matchbox cars or Hot Wheels that are smaller versions of a big car. So that's what a scale is. So let's talk about Trent and his 30-mile bike ride. And he goes on this 30-mile ride every Saturday. And it takes him 4 hours to do it. And at this rate, how far can he ride in 6 hours? So the how far, every word problem will ask you at some point what they're looking for. So they're asking for how far can he ride in 6 hours. So that was our answer. We're looking for distance here. Okay? So in the first couple sentences, kind of break it down for you. He takes a 30-mile bike ride every Saturday, and he rides the distance in 4 hours. So that kind of gives you your first ratio right off the bat. Is he's got 30 miles, and it takes him 4 hours to do it. Okay? And you're going to see, I know I'm going to set up an equivalent fraction or a proportion here, but when I do it, what I've got to do is I'm already put my miles here, and I'm going to put my hours down here. I've already put my labels because I know that I want to keep them on the same side. If miles is on the top as the numerator, I want to keep it as the numerator on the other side of the equal sign. If hours on the bottom, I want to keep it hours on the bottom of the other fraction. So they're asking how much can you go in 6 hours. So in this case, I'm going to put x, because that's the how much, that's the how far is x, we don't know. And then we've got 6 hours here. That's our question mark. Okay? So cross multiply, or you could simplify. You can use either strategy here. But I'm going to cross multiply. I just think it's easier. 30 times 6 gives us 180. And then 4 times x gives us 4x. And now we're dividing by 4 on each side. So x would give us about 45 miles he could go in 6 hours. So that was solving a problem using a proportion, solving a problem. Now if we wanted to find a unit rate and say, well, how much did he go per hour? How far did he go per hour? Well, we could just simply take these 30 and we could divide it. 30 divided by 4 is 7.5 miles per 1 hour. And you could do a cross product there too and put 1 in for your hours and x in for the miles and do that. Or you could just make the unit rate. Either way, I want to see your work. Show me that you're dividing to get to 7.5, or show me your proportion work on that side. Okay. The next problem in a road atlas, the scale of the map of Connecticut is 5 inches to 41 miles. What is the distance represented by 2.5 inches on the map? And you might be able to figure this one out just for using mental math. But again, we want to set a proportion. That's what we're working on here. So 5 inches equals 41 miles. And we want to find what is the distance. What's the distance represented by 2.5 inches on the map? So this is what we talked about the scale. And maps being used with scales all the time, or scales being used on maps all the time. So the first thing we have is 5 inches. That gives you your first proportion is 41 miles. So what would 2.5 inches represent? And again, what's the distance? That's what they're asking for. So that would be our x right here in miles. And I think you guys can go from there. We set it up for you. I think you guys can figure that one out. Okay. Next is the lesson summary. I just want you to explain in your own words how to cross multiply. So don't just copy verbatim what if you were to tell someone on the street, and this happens all the time, someone comes running up to you, hey, how do I cross multiply? How would you explain it to them in your own words? And then we have a simple cross multiply solve, so solving proportion here on the next one. Okay? So hope you enjoy that one, and that's all we got today, and we'll be ready to go tomorrow on it. See you later.